In this video, I am going to simplify this given rational expression. Before I solve the problem, let me do something on the side just to remind you of a property of exponent. It's rather a definition. If you have a to the power negative m, we define it to be 1 over a to the power m. That's the definition, given that a obviously is not equal to 0. So this is the definition that I'm going to use in order to simplify this expression. Now, if I do that, I get the following. This is what I get. Please note, x to the power negative 2 is 1 over x square times 16 is 16 over x square. Similarly, simplify this. 24 times x to the power negative 1 is 24 times 1 over x, which is 24 over x. And in the denominator, 16 times x to the power negative 2 is 16 times 1 over x square. And then that becomes 16 over x square. Now let's look at the denominators in the numerator, meaning this x and x square. X and x square. The LCD of these two numbers is, by the way, x square, because x goes into x square and x square goes into x square. So LCD is x square. In the denominator here, we find only x square, so the LCD must be x square. So the numerator and the denominator, so the numerator and the denominator both have the same LCD, x square. So what I am going to do, multiply this by x square and multiply the denominator by x square. Now it's like multiplying and dividing by the same number, so they technically cancel out. So you are left with the original expression. So you are not making changes to the original expression, you are just kind of modifying it by multiplying by x square and dividing by x square. And you get it back when you cancel this x square and x square out. But you don't want to cancel it. Okay, sometimes students make this mistake. They multiply it by x square or some term and then they would cancel it out. That beats the purpose. You want to keep this x square or the LCD that you are multiplying by, and then you want to simplify it. Now I'm going to use the distributive property. X squared times 9 is going to give me 9x squared. Then x squared times, so let me do this one on the side, x squared times 24 over x. X goes into x squared x times, so that's going to give me 24x. So it's going to be negative 24x, and then plus 16 over x squared times x squared. Again, I'm using distributive property. That gives me just 16. And in the denominator, x squared times 9 is going to be 9x squared. Then 16 over x squared times x squared is going to be 16. Now we can simplify this given expression. The denominator is easy to simplify, which is difference of squares. I could write it as 3x whole square minus 4 whole square. And the numerator, I'm going to factor it out. I'm going to write 9x squared minus 12x minus 12x plus 16. Then I'm just going to factor things out. In the denominator, it's easy to simplify using the difference of squares. It's going to be 3x plus 4 times 3x minus 4. The difference of squares formula, you do remember it, a square minus b square is equal to a plus b times a minus b. I have used this formula to simplify this. In my context, a is 3x and b is 4. Now on the numerator, look at this. I'm going to create groups. So it's factoring by grouping. So what do I have? In the first one, I could factor out 3x. If I did that, I'm going to be left with 3x minus 4. In the second group, I could factor out negative 4. That's going to give me 3x minus 4. Now I can continue. So I have 3x minus 4 here, 3x minus 4. I can factor that out, 3x minus 4. If I factor out 3x minus 4, I'll be left with 3x here. And if I factor 3x minus 4 from the second term, I'll be left with negative 4. Oh, by the way, they are the same, so it's a perfect square, right? So in the denominator is 3x plus 4 times 3x minus 4. Now as you can see, we can do some cancellations here. 3x minus 4 and 3x minus 4 cancel out. That leaves me with 3x minus 4 in the numerator, and in the denominator is 3x plus 4. And by the way, that's your answer. I hope that this discussion was helpful. Thank you very much.